Hi students, welcome to HSC Chemistry and the acidic environment video series. In this video we're going to be looking specifically at refluxing. When we're carrying out our esterifications, we have a couple of challenges associated with the process. First of all, at room temperature, the temperature is low enough to result in a very slow reaction rate. So at room temperature, the esterification process occurs very, very slowly. Esterification is a reversible reaction, that is an equilibrium, and hence it does not go to completion. The reactants and the organic product is volatile. Now the water isn't, and I guess the organic acid to a certain extent is not particularly volatile, certainly not flammable, but they all are relatively volatile. They all have a fairly distinct aroma, and that transition from liquid to gas occurs very readily. And so therefore, both your reactants and your organic product are volatile, and the liquids and vapors can also be flammable. This is particularly true of the alcohol and also of the ester. So what can we do in order to speed the reaction up, to try and get the reaction rate to increase, to favor the forward component of this reversible reaction so that we maximize the yield of the ester, and also to try and keep ourselves safe against the potential odors that are created, and also the flammability of any vapors that may be near, say, a Bunsen burner flame? Well, the way we overcome that is through a process known as refluxing. Effectively, this is about having a vertical condenser. So where we have previously looked at condensers sitting horizontally or at a slight angle as the gases that pass into them cool in the condenser and then drip into another place as we separate those off, which is our normal distillation process. In this particular process, the condenser is actually vertical. And what that means is any of the vapors that are actually condensing in the condenser are going to drip back down into the reaction vessel. So this here is our reaction vessel. And it's often a round bottom flask like the one that you can see here. You can notice too that the way that this diagram's been set up, the heat source is coming not from a naked flame, but actually from a heating device that is allowing the heat to be regulated without the need for a naked flame. Boiling chips are often used as well, which encourages the mixing so that the two reactants will mix. Also create a larger surface area, so often you will get some vaporization occurring, some bubbling that's occurring on those marble chips, and the fact that they bounce around allows them to continue to stir through that mixture. This heating mantle that you can see can also be replaced by a water bath, so we could actually use a Bunsen burner, put our tripod, a gauze mat, put a large beaker, and then submerge our reaction vessel into the beaker so that it sits there being warmed in a more controlled manner. The fact that this is also an open system, we know that one of the conditions for equilibria is that the system is closed and therefore equilibria can establish. So if we open the top of the condenser, then some of the gases will escape. We do have that problem with volatility and potential flammability, but if we can keep the gases away from a naked flame, then we can also get some of those gases to escape from the reaction vessel. Potentially some of that will be the ester that you can smell, and that hopefully will result in the reaction continuing through to establish a higher yield of our ester. So then one of the things that you may have to write about are the advantages of refluxing, or why we use refluxing as a technique. So there's a couple of very important ones. The first one is the use of higher temperature, and of course higher temperatures means an increase in the kinetic energy of the particles, and this means they are more likely to, there are more of them that will average out at that sufficient activation energy in order for the reaction to proceed. So increasing the temperature increases the kinetic energy of the particles, means more of them are likely to have reached sufficient activation energy to react. The cycling of gases through our reflux reduces the loss of the volatile reactants and also reduces the losses of the products and allows us to recycle some of those reactants in order to try and increase the yield of the ester. Now, very importantly, one thing we haven't talked about when discussing the use of refluxing is the use of a concentrated sulfuric acid catalyst. And this too is going to speed up the reaction rate, although it will not affect the position of equilibrium. All it does is allow us to reach that equilibrium much quicker. So this is going to be concentrated sulfuric acid as our catalyst, a few drops in there, which will help catalyze the reaction, dehydrate the water molecules away from those two reactants in order to encourage them to form the product. Refluxing is an important technique, and it's one of the things that goes hand in hand with the process of esterification. Thanks for watching.